We were talking of completing the square in our previous lesson. But don't forget to complete your learning of a topic and never leave it halfway. For that very reason, I have brought one more example question for you. That is 2x squared minus 5x minus 3 is equal to 0. What should we do first with this equation? Yes, firstly, we make the coefficient of x squared equal to 1. For that, we divide the equation with the coefficient of the given x squared. Here, that is 2. Divide the equation by 2. Secondly, shift the constant term minus 3 upon 2 to the right side. The new equation is named equation number 1. Now, the next step is to take half of the coefficient of x, or in other words, multiply it with 1 upon 2. Doing that to negative 5 upon 2 will give us negative 5 upon 4. And then add its whole square to both sides of equation 1. Moving to the fourth step, simply compare the left side of the equation with the perfect square formula to turn it into a perfect square. Here a is x and b is negative 5 upon 4. In light of this formula, we will just close this side as x plus minus 5 upon 4 whole squared, or simply x minus 5 upon 4 whole squared. Don't ignore the other side. Simplify it by squaring minus 5 upon 4 to get 25 upon 16. For simplifying it more, we are taking the LCM, which turns out to be 16. Now, just add these. 25 plus 24 is 49. And that's pretty much it. Then it's time to get rid of the square. Yes, the fifth step. It's taking the square root on both sides of the equation. By cancelling the square with the square root, we have two values. Either x minus 5 upon 4 is equal to 7 upon 4 or negative 7 upon 4. To isolate x, we shift minus 5 upon 4 on the right side of the equation. Add and subtract them. And with the use of simple math, this turns out to be 3 and this minus 1 upon 2. Thus, we have found the roots of the given equation, which can be written in brackets as the solution set. This is how you solve a quadratic equation by completing the square. You already know how to solve it by factorization. Why don't you practice these on your own while I come back with another lesson about quadratic equations?